So flow logic and productions leveling. Why do it? What is the point? The point is you're trying to create what's called economies of repetition. There's three factors to economies of repetition. Firstly, learning curve. If you do the same thing at the same time every week, you'll just get better and better and better at it. You don't have to teach people continuous improvement. It just happens. So doing the same thing every week at the same time, you will get better. Secondly, routines. Routines are different to learning curve. People love routines. It gives them a structure. They need less supervision. It's more empowering. People absolutely love routines. The problem is with batch logic, when there's a different plan every time and it normally changes, it's impossible to have routines. Let me give you a little funny example of a routine. Go into your car park at work one day, draw a map of where the cars are parked. Go back the following day at the same time and look at where the cars are parked. And you'll find an awful lot of cars will be parked in more or less exactly the same place. Lastly, stability. Stability is absolutely fundamental for sustainable continuous improvement and root cause problem solving and resolution. It also encourages standardization. In a batch environment where it's a different plan every time and it changes, getting everybody to do things the same way is practically impossible. Whereas if it's always the same, people begin to understand the sense in standardization, everybody doing it the same way. It's much easier to get standardization, which is a fundamental aspect of Lean, where the plan is the same every week. So, flow logic and level production. Seems ridiculous and stupid. So the big question is, how to start? Well, this is where I developed a little tool to help called the Glenday sieve. It's called Glenday because I invented it, and it's sieve because it sieves the products into different categories. Let me show you what I mean. What you need to do is to list your products from the biggest to the smallest and then calculate the percent cumulative sales. Come down until you reach 50% cumulative sales and then look at how many products give you the 50% cumulative sales, the biggest products, and calculate that number of products as a percent of the total product range. And the answer you will get, 6%. It is unbelievable. It doesn't matter what you make, doesn't matter what your business is, it invariably is just 6% of the products give you 50% of the volume that you make. And we call those the greens. Then come down to 95% cumulative sales, and again, calculate what percent of the product range gives you 95% of the sales? And the answer will be 50%. And we call those the yellows. Then come down to 99%, and you'll discover that typically 70% of the products are 99% of the sales, which for the mathematically minded among you, you'll realize that 30% of the products is just the last 1% of sales. And we call those the reds. Quite why we would make that 30% of the product range when they're only the last 1% of sales is a good question, but not one to cover in this presentation. What we want to focus on are the greens. 6% of the products, 50% of the volume. A small number of high volume products, and we want to put those into a fixed repeating plan. Fixed repeating plan, ideally weekly, the same every week. But, and this is a big but, the common perception is that your sales are very, very variable. How can you possibly have a fixed production plan with the same volumes every week when your sales are so variable? But this common perception is wrong. It's wrong. Let me show you what I mean. This is data from Kimberly-Clark. You all know Kimberly-Clark. This is Kleenex tissues in America. What we have here is a big volume product, a green code, and a small volume product, a red code with the week by week actual sales during the month, these weeks in the summer. And at the bottom of the table is the average weekly sales for each product. The green product varies in cases from 14,355 cases a week to 17,777 cases a week. Huge variability, most people think. The reds, oh, they only vary a couple of hundred cases. That's not much. But the greens, huge variability. That's the perception. But you shouldn't be looking at unit variability. What you need to look at is percent variability. So each week, what percent difference is there between actual weekly sales and the weekly average? And when you take a look at that, it looks a bit different. Here we have it. The greens vary, the weekly sales compared to average vary from 89% to 110%. The reds vary from 13% to 231%. So when you look at the percent variability week on week, it's a very different picture to the unit cases variability. But people's perception is based on the unit cases variability, not the percent. So let's take a look at that in a graph. So if we take average weekly sales as 100%, you can see the greens vary very little around that average. The reds, on the other hand, highly variable. So the perception is based on the unit cases, not the percent variability. So when we've got that, remember the buffer tank? We're trying to replicate how a real buffer tank works. Well, we can now put limits around the green. We don't need a very big buffer tank. As you can see, it's quite small, possibly plus or minus 15% of average weekly sales. That's all. Now, if you produce in your fixed plan exactly the same volume every week, replenishing that buffer tank, the buffer tank will take care of the actual sales variability, excuse me, compared to the average. That way you can make exactly the same every cycle, and the buffer tank will take care of the differences between actual sales and the average production. That means you've got stability. That means, right, that you can get economies of repetition, routines, learning curve, and sustainable continuous improvement, root cause problem solving and resolution, standardization, all the things that make you better and better and better. So whilst it's true, it looks ridiculous and stupid at first to have a fixed repeating schedule, you need it to create stability. That's what Toyota understood. Create stability, eliminate the firefighting that batch logic causes. You need to change from batch to flow, from an unstable process to a stable process that will then create the foundation for sustainable continuous improvement, root cause problem solving, and standards.